welcome. Thank you for joining us here at Labtech Engineering, a global leader in designing and manufacturing advanced laboratory and pilot plant equipment for the polymer industry. In this video, we will be providing a comprehensive, in-depth guide to the operation of our laboratory compact filter tester, the model LCFT34-GP. This machine is an indispensable instrument for research, development, and quality control, engineered to deliver precise, repeatable data on the dispersion quality of pigments, additives, and fillers in thermoplastic materials. The system is comprised of three main, integrated sections that work in concert to perform the test. First, the single-screw extruder, which processes the material. Second, the computerized control panel, which serves as the brain of the operation. And third, the gear pump and filter head assembly, where the measurement takes place. Let's examine each of these in turn. First is our high-performance single-screw extruder. This unit is responsible for melting and preparing the polymer sample. It is equipped with a 20 mm diameter screw and features an LD ratio of 30:1. Next, we have the computerized control panel. This is the command center for the entire operation. You will notice two distinct software interfaces that operate individually. The first is the extruder control interface. Its dedicated function is to set, monitor, and control the temperatures for all heating zones along the extruder barrel and for the gear pump. The second is the filter test control. This is the primary interface for managing the filter test. From here, the operator will initiate the test, monitor the real-time graphical data, and ultimately save and analyze the results. We will explore its functions in detail later in this guide. The final core component is the gear pump and filter head. After the material is melted in the barrel section, it is fed into this gear pump. The pump's function is to deliver a perfectly constant flow of polymer to the filter. This precision is the heart of the test's accuracy. This filter head is fitted with two crucial pressure transducers, identified as PS1 at the pump's inlet and PS2 at the outlet, just before the filter screen. The first transducer, PS1, is part of a closed-loop control system that automatically adjusts the extruder's screw speed. In compliance with the EN 13900 standard, the testing process is recommended to maintain a constant melt pressure of 50 bar at the gear pump inlet. The second transducer, PS2, is positioned to measure the melt pressure buildup directly at the screen pack. The data from PS2 is the primary measurement of our test, as it directly reflects how quickly the filter is becoming blocked by undispersed particles. The screen pack itself, where the filtering occurs, is housed directly in front of the PS2 transducer. Inserting it is a straightforward process. First, you untighten the handles on the front of the nozzle by turning them counterclockwise. This allows you to carefully withdraw the screen pack retainer. You then place the new screen pack into the recess within the retainer. It is absolutely essential that the finer mesh of the screen pack is positioned to face the direction of the incoming polymer melt. With the screen correctly oriented, you reinsert the retainer into the filter tester head and firmly tighten the handles to create a secure, leak-proof seal. Operator safety is a non-negotiable principle in Labtech's design philosophy, and the LCFT34-GP is fortified with multiple protection features. The emergency stop push button, when pressed, immediately cuts all power to the motors and moving components of the machine. The main power safety switch, located on the electrical cabinet, ensures that the main power supply is fully isolated before any access to high voltage components. In addition, for thermal protection, a protective steel guard is fitted over the filter tester head, and a complete barrel safety cover extends over the entire extruder barrel. Both are designed to prevent accidental contact and burns. And for overpressure protection, the system includes two high melt pressure emergency rupture discs. One is fitted at the end of the extruder barrel, and a second is on the filter tester head inlet. These are critical safety devices that protect both the operator and the machine from damage due to excessive pressure. Let's now take a closer look at the filter pack, the component that is the very heart of the test. Labtech provides a wide range of filter packs that adhere to the EN 13900 standard, ensuring that results are consistent, repeatable, and comparable across different laboratories. Briefly, our filter packs are available in several sizes, with the 34mm and 44mm models being the most commonly used. For our standard 34mm filter pack, we provide ISO and EN compliant packs designated as Screen Pack 1, 2, and 3. Furthermore, we also have custom filter packs for both the 34 and 44mm heads. These are available in a range of nominal aperture sizes, including 5, 10, 15, 25, and 45 microns. Each of these packs is constructed with a robust 3-layer support system. We will now walk through the complete step-by-step procedure for conducting a filter test. First is the preparation and purging phase. You will switch on the main power supply to the unit and ensure the cold water supply to the extruder is active. The main control panel will power on and the operating system will initialize. From the desktop, you will then open the extruder control interface program. As soon as the program loads and communicates with the machine's sensors, an alarm will sound. You can then press the alarm button on the screen to silence the sound. Now is the time to set the target temperatures for your specific base polymer and master batch. Note that the alarm light will continue to flash. This is normal, as it indicates a difference of more than 10 degrees between the set temperature and the actual machine temperature. The flashing alarm light will extinguish automatically once the actual temperature of the machine reaches the set point. The initial step is to thoroughly purge the machine. This is done without a screen pack installed, using only the pure base resin that will be used in the test. To prepare for this step, insert the empty screen pack retainer back into the filter head, and then firmly tighten the handles on the front of the nozzle to create a proper seal. This machine uses a unified process for both purging and the actual test, so we'll now input the standard operating parameters. First, on the extruder control interface, set the gear pump speed to the standard 20 RPM and the target inlet pressure for the closed loop control to 50 bar. Next, it is critical to tare the pressure by pressing the tare icon. This establishes a true zero pressure baseline before you begin. Once these values are set, activate the closed loop pressure control. Now we begin the purge by pressing the start button for the gear pump first, followed by the start button for the extruder screw. You will notice that upon starting the extruder, the system does not abruptly jump to the target pressure. Instead, the machine initiates a gradual ramp up of the screw speed. This is a key feature of our advanced programming, designed to simplify the process and make it exceptionally user-friendly. This soft start sequence prevents sudden pressure shocks to the system and eliminates the need for manual adjustments during startup, allowing for a smooth and controlled initiation of the melt flow. Starting the gear pump first ensures there is a path for the melt to travel as soon as the extruder begins to feed it. The purge is complete when clear. Virgin resin is seen extruding from the nozzle. Once the system is clean, stop the process by turning off the extruder screw first, followed by the gear pump. The second phase is the final test setup. With the system now clean, we prepare for the actual measurement. The operating parameters of 20 RPM and 50 bar are already programmed from the purging step, so there is no need to change them. The critical action now is to install the new clean filter screen pack as previously demonstrated. After installing the screen pack, allow the machine approximately 30 minutes for the temperatures to fully stabilize throughout the head assembly. Just before starting the actual test, it is essential to tare the pressure one more time. This ensures that any minute pressure variations from installing the hardware are zeroed out, providing a perfect baseline for the test data. Once tared, you will start the machine in the same sequence as before. Press the start button for the gear pump, and then press start for the extruder screw. The closed loop system will now begin to work. You will observe the inlet pressure, P1, climb, and then hold steady at the 50 bar set point. Once the machine has achieved this, a stable indicator will appear on the screen, signaling that the system is running under ideal, consistent conditions, and is ready for the sample introduction. The third phase is operation setup. On the filter test control screen, press the new button to begin a new test file. Proceed to populate all the blank boxes with the test information, such as sample ID, date, operator name, pigment. As the hopper level of virgin resin becomes low, add the weighed test sample. The test has now officially begun. press the Start button on the main filter test screen to begin recording data. The software will now plot the pressure buildup at the screen pack P2 in real time. As the test sample in the hopper runs low, add extra virgin resin to flush the entire sample. When this final charge is nearly depleted, click the End button on the screen. Finally, click the Save icon. The system will request you to name the file, storing the complete data set, including the graph and all calculated values for analysis. Now stop the extruder first, followed by the gear pump. The test is now complete. The software automatically calculates and displays the delta P and filter pressure value, or FPV, for the completed test. It is recommended to replicate this test at least 3 times for each sample. You can then compare the FPV results and also overlay the graphs from each run to visually confirm the consistency and quality of your master batch. So what is the fundamental purpose of this detailed procedure? The Labtech filter tester serves as a critical quality control methodology. Its primary function is to provide a quantitative assessment of the dispersion quality of additives within a polymer. We hope this detailed walkthrough has been highly informative and has provided you with a clear, functional understanding of the machine's sophisticated components and testing procedure. Thank you for your time and attention. For any further inquiries, to request a quotation, or to discuss how this instrument can advance your quality control processes, please feel free to contact us through our official website or your local Labtech representative. We look forward to partnering with you.